Hello, we will learn how to draw the projections of a straight line when it is inclined to both the horizontal plane of projection and the vertical plane of projection. HP and BP are the planes of projections. AB is the line which is inclined at an angle of theta to the horizontal plane and phi to the vertical plane. Since the line is inclined to both the planes of projections, neither the front view nor the top view shows the true length of the line. Also, the front view will be inclined at an angle greater than theta. Similarly, the top view will be inclined at an angle more than the angle phi. Therefore, we cannot draw the projections of the straight line directly when it is inclined to both the planes of projections, because we cannot see the true size neither in the front view nor in the top view, and also the angles at which the front view and top view are oriented is more than the true angles of inclinations theta and phi. But we can imagine projectors from A and B to the vertical plane and obtain point A dash B dash, draw the front view. Similarly, projectors from A and B to HP will give us the top view. We know A dash and A lie in the same straight line, so this is the straight line, and similarly B dash and B lie in the same straight line. So this we can imagine, but without knowing A dash B dash length and AB length. Also note A dash B dash inclination with the horizontal plane is more than theta, and the top view inclination with vertical plane is more than phi. And hence we cannot draw it on the drawing sheet, because in the problem statement usually the true length and true angles of inclinations theta and phi are given. Then how to draw? For that, we assume the line AB is rotated about A. So in which direction and to what angle, and how the rotation of line AB about A will help us to draw the projections, we will see now. So what we can imagine is shown here, and we assume the line AB is rotated about A. For that, the enlarged view of the line is shown here. The line is AB, and its corresponding top view alone is imagined, or it is shown here, drawn here. The black color lines capital B, small b, capital A, small a are the projectors, and AHPA1 is distance of point capital A above horizontal plane, and this is distance of point B above horizontal plane. So why it is 1 suffix? Because this is corresponding to the position 1. So what is that position 1? Position 1 is the actual position of the line as given in the problem statement. That means the line AB is inclined at an angle theta and phi to the horizontal planes and the vertical plane. In this position, the top view length is L. Now we are going to rotate this line about A. How? Do not change theta. So we are going to keep theta as such, but vary phi. How to do that? Here, once again, the line AB is shown in its given position for reference. Suppose if I rotate this. So how it is rotated? The line is rotated in anti-clockwise direction about A, meaning position of A is fixed, only B gets changed, and it is rotated such that the line becomes parallel to the VP. So in the new position, the line is parallel to VP. What about its relation with HP? The angle theta is maintained. We are not altering the value of theta. So only phi is varied. Corresponding to this position, what is the top view? We need to draw the projectors and then connect. So this is the corresponding top view. And of course, this is point A, this is point B, this is small a, this is small b. So after rotation, what we infer is the height of the point A above horizontal plane in position 2 and the height of the point B above horizontal plane in position 2 are equal to the corresponding positions in position 1. What is the meaning of this? Whatever be the value of phi, height of point A and B above horizontal plane remains the same, provided theta is unaltered. What about the top view? Top view is AB. In order to distinguish between position 1 and 2, we use suffixes 1 and 2. And from the geometry, we can easily infer the top view in position 1 and top view in position 2 are equal. What it means is, whatever be the orientation of the line or whatever be the angle of phi, top view remains the same, provided theta is constant. So we do not change theta, we vary only phi. Phi may be equal to 10 degrees, 5 degrees, 15 degrees, 120 degrees, 180 degrees, 270, 235, 360, 345, whatever be the angle of phi, height of point A and B above horizontal plane remains the same and length of the top view also remains the same, provided theta is not changed. Provided theta is not changed. So this inference, height of points above horizontal plane are equal and top view remains the same are important. So these are the inferences which we will use in order to draw the projections. And if you take a close look, in position 1 we have a trapezium A, A, B, B. So this trapezium is formed by the actual line and its corresponding top view and the projectors. What happened to this trapezium in position 2? We notice from the geometry trapezium ABBA orientation is changed and not size. Just orientation. That means the angle phi is varied. The size remains the same. What is that size? Height of points A and B above the horizontal plane and the top view length. Top view length. Now imagine the line and its corresponding front view. The distance of point B in front of vertical plane is given as IVP B suffix 1. This corresponds to position 1. What is this position 1? It is the actual position of the line with respect to the problem statement. So in this position, line is inclined at an angle theta to the horizontal plane and phi to the vertical plane. So capital A, capital B, B dash, A dash form a trapezium. So here is that trapezium, so which we imagine. Now we are going to rotate the line. This time we are going to vary theta and keep the value of phi as such. So phi is unaltered. Theta is varied. For reference, the actual position of the line AB is drawn here once again. This line is inclined at theta to the HP and phi to the vertical plane. Now it is rotated. After rotation, the line becomes parallel to HP. So what is assumed is the line B is rotated in clockwise direction about A, meaning position of A is unaltered, only B is altered such that the line becomes parallel to the horizontal plane. How do we say the line is parallel to horizontal plane? Because the points A and B are at equal distance from the horizontal plane, and this is the corresponding top view. In position 2, the line is parallel to HP. Therefore, top view shows the true length of the object. So this is our imagination or our assumption. This is not the true condition. True condition is it is inclined at an angle theta. So when it is parallel to HP, what is its orientation with respect to vertical plane? So the orientation with respect to VP remains constant. That means we do not change phi. And in this position, we can draw the corresponding front view. A dash, B dash, this one. So phi is not changed, only theta is changed. So to this new position, we have drawn the projection. A dash, B dash is the projection. What is the inference? The distance of the point B in position 2 is equal to the distance of the point B in position 1. The same condition applies to point A also, which is not shown here. What we discussed in the previous case is equally applied to here also. Now what happens to this front view A dash B dash? From the geometry, we easily understand A dash B dash corresponding to position 1 and 2 are equal. In position 1, the trapezium is A, B, B dash, A dash. In position 2, the trapezium is A, B, B dash, A dash. A close observation will show you trapezium AB, B dash, A dash orientation is changed and not size. That means the length A dash, B dash and the distance of the points A and B in front of the vertical plane are one and the same in both the positions. This is because we varied only theta. Phi remains the same, it is unaltered. So what is the inference? Whatever be the value of theta, the distance of the point in front of the vertical planes and the corresponding front view are equal, provided phi is unaltered, meaning the value of phi is equal to the value given in the problem statement. We are going to draw the rotation of line AB about A and the inferences we discussed on this three-dimensional imagination of projection of the straight line AB and learn how to draw the projection of a straight line when it is inclined to both the planes of projections. Now assume the line AB is rotated about A in clockwise direction. This is the direction of rotation. In this position, the line becomes parallel to HP, join A and the new position of B. While doing so, the angle of inclination of the line with VP remains the same. Phi remains constant. And corresponding to this new position, obtain the top view of point B and name that as B2 to differentiate between the earlier top view of point capital B. Join A and B2. So what is this A, B2? This is the true length of the line when it is assumed to be parallel to the horizontal plane and inclined at an angle phi to the vertical plane. From our inferences, we know both point small b and B2 are at the same distance in front of the vertical plane. Therefore, we can draw a line through B and B2 and that line is called locus line. This locus line is parallel to the reference line or the XY line. Now we can rotate the line about A in anti-clockwise direction so that the line becomes parallel to VP, and green color line after rotation is drawn is parallel to VP but at the same angle theta to the horizontal plane. We can draw the corresponding front view of point B. So that is B1 dash. So B1 dash is the front view of point capital B when the line is assumed to be parallel to VP and inclined at an angle theta to the horizontal plane. Now we can join A dash and B1 dash. A dash B1 dash is the true length of the line in the front view, and from our inference we know B dash and B1 dash are at equal distance above horizontal plane. Therefore, we can draw a line through B dash B1 dash and that line is called a locus line. So this locus line is also parallel to XY or the reference line. Now, we don't know what is the length of A dash B dash and AB. In order to know the length of A dash B dash, draw the front view of the line assuming it is parallel to HP and inclined at phi to VP. When it is parallel to HP, we can see the true length and the true length is AB2. So project AB2 to obtain the front view. So how to do that? From B2 draw a projector. From B2 draw a projector until it meets the XY line. And from that point draw a vertical line. Draw a vertical line. So this is the projector from point B2. The other end of the true length line is A. The projection of point A is already drawn here, that is A dash. And now to obtain the front view corresponding to this true length AB2, draw a horizontal from A dash. So that will intersect at point B2 dash. So AB2 is the true length of the line when it is parallel to HP and inclined at an angle phi to the vertical plane, and the corresponding front view is A dash B2 dash. From our earlier inference, whatever be the angle of theta, front view remains the same as long as phi is constant. Therefore, A dash B dash, which is the front view corresponding to the line A to B2, also equal to the front view A dash B dash. Therefore, A dash B dash length can be obtained by drawing the true length in the top view, assuming the line is parallel to HP and inclined at an angle phi to the vertical plane, and project its corresponding front view A dash B2 dash. Now to obtain point B dash on the locus line, what we can do is fix A dash as center and A dash B2 dash as radius, draw an arc. Draw an arc. Definitely that arc will pass through A dash B dash, B dash. Similarly, to obtain the top view length AB, draw a projector from B1 dash until it meets XY, this vertical line. And again, from that point, draw a projector. So one end of the line is B1 dash, the other end is A dash. A dash corresponding top view, A is already drawn here. So from A, draw a horizontal line. Draw a horizontal line. Both will meet at the point B1. So A, B1 is the top view corresponding to the true length A dash B1 dash. A dash B1 dash. From our earlier inferences, we know whatever be the angle of phi, the top view remains the same as long as theta is maintained constant. Therefore, AB1, which is the top view, obtained by assuming the line is parallel to VP and inclined at an angle theta to the horizontal plane, is equal to the actual top view AB. Therefore, AB is equal to AB1. Now what we can do is fix A as center and AB1 as radius, draw an arc. That arc will definitely pass through point B. So this completes our projection, and before going to the procedure of drawing it in a drawing sheet, observe AB2 is inclined at an angle phi. Similarly, A dash B1 dash is inclined at an angle theta. So theta and phi are the true angle of inclinations because AB2 is drawn assuming the line is parallel to HP. Therefore, we will see true angle of inclination phi in the top view. Similarly, theta. Now, what is the angle of A dash B dash? A dash B dash is at an angle alpha, which is greater than theta. Similarly, AB is at an angle beta, which is greater than phi. And this alpha and beta are called apparent angle of inclinations. Theta and phi are the true angle of inclinations. True angle is visible only when the line is parallel to the particular plane of projection. Now, what we infer is A dash B dash is equal to A dash B2 dash. So A dash B dash is equal to A dash B2 dash. What is this A dash B2 dash? A dash B2 dash is equal to projection of AB2. So where is AB2? AB2 is in top view and its corresponding projection, that is the front view, is A dash B2 dash. How to obtain this AB2? By assuming the line is parallel to HP and inclined at an angle phi to the vertical plane. Similarly, what is AB is equal to AB1. So AB is equal to AB1. So what is this AB1? AB1 is the projection of A dash B1 dash. So what is this A dash B1 dash? A dash B1 dash is the true length of the line in the front view. This is drawn assuming the line is parallel to VP and inclined at an angle theta to HP. The projections we discussed are shown here. Now we are going to draw the required projections in the drawing sheet. The required projections are A dash B dash and AB. For that, draw the XY line first. So XY line is the reference line. And mark the position of point A dash. So A dash is in the front view, which comes above XY line. And through A dash draw a horizontal line, and at an angle theta draw a line. At an angle theta draw a line, this green color line. Theta is this angle. That means the angle of inclination of the line with HP. On this green color line, obtain point B1 dash. So we can obtain point B1 dash on this line. Take the true length of the line. Remember, A dash B1 dash is the true length, because this line is obtained by assuming AB is parallel to VP and inclined at an angle theta to the horizontal plane. So measure or take true length in your compass, fix A dash as center, cut an arc and obtain B1 dash. So the distance between A dash and B1 dash is the true length TL. We know B1 dash and B dash lie on the same horizontal line. That means at equal distance above XY line. So we know the position of B1 dash. Therefore, we can draw the locus line. That means draw a horizontal line through B1 dash, and that is the locus of B dash. What it means is definitely point B dash will be located on this line, horizontal line. Now project point A in top view. So this is point A, top view point. So that is drawn. Now we can draw AB2. So AB2 is at an angle phi. Phi is the true angle of inclination. Therefore, through A, draw a horizontal, and at an angle phi, draw a line. AB2, AB2 is the true length because it is assumed, sorry, it is drawn assuming the line is parallel to HP, inclined at an angle phi to the vertical plane. So take the true length in your compass, fix A as center and cut an arc and obtain point B2. So AB2 is equal to true length. We know B2 and B lie on the same locus line. That means the distance of both the points in front of the vertical plane is same. Remember, the distance in front of the vertical plane in a drawing sheet is drawn below XY line because the space below XY line represents horizontal plane. Therefore, through B2, draw a horizontal line. That is the locus of B. What it means is definitely point B will be on this horizontal line. Take a recap. Usually in the problem statement, distance of point A above HB is given. Therefore, we can easily draw A dash. Similarly, the true angle of inclination theta is also given. Therefore, we can draw this line from A dash. Also, true length data is given in the problem statement in general. Therefore, we can mark point B1 dash and through that we can draw a horizontal. Similarly, distance of the point A in front of the vertical plane in general is given, and the true angle of inclination of the line with vertical plane is given. Therefore, we can draw this blue color line and obtain B2 from the true length data, and we can draw a line through B2, a horizontal line through B2, and that is the locus of B. But what is our aim? Our aim is to draw the projections. What are the projections? Projections are A dash, B dash and AB. How to know the lengths A dash, B dash and AB? We know top view length AB is equal to AB1. What is this AB1? AB1 is projection of A dash B1 dash. Projection of A dash B1 dash. So A dash B1 dash is here. Therefore, draw a projector from B1 dash. Draw a projector from B1 dash. And here through A we need to draw a horizontal, and that horizontal is already here. The projector from B1 dash meets the horizontal through A at this location, and that point is B1. And we know AB, this AB is equal to AB1. AB is equal to AB1. In the drawing sheet, we know the position of A, but not the position of B. But we know definitely B will be on this line. And also we know AB is equal to AB1. Therefore, what can we do is fix A as center and A B1 as radius, draw an arc until it cuts locus of B. So A as center, A B1 as radius, draw an arc until it cuts the locus of B, and that point is B. Now B is located here. What can we do is we can join AB. So this completes the top view. What is left out? We need to locate point B dash. That means we need to draw A dash B dash, that is the front view. And this A dash B dash is equal to A to B2 dash. A dash B dash is equal to A dash B2 dash. So what is this A dash B2 dash? A dash B2 dash is projection of AB2. So where is AB2? It is the top view. So top view AB2 is here. Draw the projection of AB2, that is obtain its corresponding front view. AB2 is the top view representing the true length, assuming the line is parallel to HP and inclined at an angle phi to the VP. So its corresponding front view is A dash, B2 dash, and this intersection point gives B2 dash. A dash position is known, locus of B dash is known. We know A dash B dash is equal to A dash B2 dash, so which is also known. Therefore, fix A dash as center and take A dash B2 dash as radius, draw an arc until it cuts the locus of B dash. The intersection point is B dash. We know both the positions of A dash and B dash, join A dash and B dash, and that is the required front view. As a cross check, We know B dash and B are the front view and the top view of the point capital B. In orthographic projections, we know B dash and B lies on the same straight line. That means they lie on a same projector. How to ensure that? Draw a line from B, that is a perpendicular line from B. Definitely it will pass through B dash. Similarly, A dash and A lie on same projector. So A dash A, B dash B lines are the end projectors, and this completes the projection of a straight line inclined to both the planes of projections in drawing sheet. Hope you understand how to draw this one. Thank you.